This lesson is to help you with the multiplication, division, and rationalization of denominators where radical expressions are involved. You probably remember this from previous lessons. So if you have multiplication going on inside the radical, then you could split those up. And sometimes that works out convenient for you. Sometimes you'll be given it like this and you want to combine them. With division, you can also split them, and it goes both ways. So if you're given it like this, then you could combine them as is on the left side. So let's look at a few examples. So this one, I think it would be convenient if I multiplied them. So that would give me the cube root of 4 times 16, which is 64. And 4 times 4 times 4 gives me 64, so the answer is just 4. Here, it would be convenient to write it under one big radical, because 50 divided by 2 is the square root of 25, which is just 5. Here, if I put all of this under one radical, and I end up with the fifth root of 32, and 2 to the fifth power is 32, so that just gives me 2. Of course, they do get a little more complicated. So you try these. Pause the video, write down the problems and work them out, and then come back and check your work. The distributive property and FOIL also work with radicals. So here, if I multiply the square root of 2 times the square root of 3, I get the square root of 6. Remember, to multiply, the roots have to be the same. When I multiply the square root of 2 times 5, I just get 5 square root 2. And there's nothing more I can do with that. I'm finished. Here, I'll multiply and get 8 cube root 4 and minus the cube root of 4 times 2, which is 8. Well, the cube root of 8 is 2, so I can simplify that a little further. The cube root of 8 is 2, so there. Okay, now when you FOIL, it does get a little bit complicated. I'm going to work it two ways. One, the box method, which is kind of what I prefer. And then I know a lot of you just use FOIL, so I'll work that out as well. Okay, so when I multiply 7 square root 2 times 7 square root 2, I get 49 times 2, which is 98. I'll go ahead and write that. Okay? And when I multiply 7 square root 2 times 5, I get 35 square root 2. When I multiply 7 square root 2 times negative 5, I get negative 35 square root 2. And negative 5 times positive 5 is negative 25. So I notice that negative 35 square root 2 and 35 square root 2 add to 0. And so then I'm just left with 98 minus 25 equals 73. And if you'll notice, when I multiplied these, my middle term added to 0. I'm showing you this example on purpose because when this happens, when you have exactly the same thing in both parentheses, but one is a plus and one is a minus, and it doesn't matter what order they're in, that's called a conjugate. When they're conjugates, you're going to end up with just a number answer. We're going to use this when we rationalize denominators. Okay, if you used FOIL here, you would just multiply those two, which gives you the 49 times 2, which is 98, and then 7 square root 2 times 5, negative 35 square root 2, and then plus 35 square root 2, and then minus 25. So you end up, those add to 0, and you still end up with the 73. Okay, now we're going to talk about the rationalization of denominators. And what this means is we're trying to get a rational number in the denominator. If you notice in all three of these examples, they have square root 5, the cube root of 2, and the square root of 5 down here. All of those are irrational numbers, and you don't want to have any irrational numbers in the denominator. So to get rid of one with a square root, I can multiply by whatever's in the square root. So in the numerator, that gives me negative 3 square root 5, and in the denominator, it gives me 2 times square root 25, which is 5. It's okay to have an irrational number in the numerator. Okay, now this one's a little bit trickier because I can't just multiply by the cube root of 2. That would give me the cube root of 4. And the cube root of 4 won't help me. So if I multiply by the cube root of 4, then I end up in the numerator with the cube root of 4, and in the denominator the cube root of 8. The cube root of 8 is a perfect cube, and that's what we're looking for. It's just 2. So this is my answer. When you have a binomial in the denominator that needs rationalization, if you multiply by the conjugate, that middle term cancels out and you get a rational answer. So in the top, I'm using the distributive property. I'll write it out for you. And in the bottom, I'm going to use FOIL. So if I FOIL it out, 2 times 2 is 4, and then that will be 2 square root 5 minus 2 square root 5 adds to 0, and then minus the square root of 5 squared, which is just 5. So in the numerator, I have 6 plus 3 square root 5, and in the denominator, I have negative 1. I can rewrite that as negative 6 minus 3 square root 5. Here's another example. This one, I'm going to have to multiply by 7 minus 2 square root 5. So in the top, I'm going to make my little box for that. I get negative 21 here, negative 7 square root 2, 6 square root 5, and 2 square root 10. So I'm going to have a rather lengthy numerator. So I have negative 21 minus 7 square root 2 plus 6 square root 5 plus 2 square root 10 over, and now when I multiply these, I get 7 times 7 is 49, and then the negative 14 square root 5 plus 14 square root 5 add to 0, and then I have minus 4 times square root 5 times square root 5 is 5. So I end up with that big long numerator, and there's really nothing I can do about it because none of them are like terms. And my bottom is 49 minus 20, which is 29.